All right, student pilots, welcome to today's explainer. We're going to get right into it and learn exactly how to navigate your cockpit instruments and actually hit your headings safely and precisely. If you've ever felt completely overwhelmed staring at that panel of dials, you are absolutely in the right place. Today, we're transforming those instruments from confusing gauges into literally your best friends in the sky. But hey, before we even glance at a single dial inside the aircraft, we actually need to talk about the world outside. Remember your absolute best pre-flight safety habit? Whenever possible, select a distant reference point to turn to out the window. Relying on a point on the horizon acts as this essential real-world backup to your instrument indications and keeps you spatially oriented. So, eyes outside first, instruments second.
So, here is our pre-flight briefing for today. We'll be covering 1. Standard rate turns, 2. The heading indicator, 3. The clock, and 4. The magnetic compass. We'll be moving right through a pilot's hierarchy of reliability.
Section 1. Mastering Standard Rate Turns, the foundation of flight. Let's dive right into this baseline concept. Pretty much every turn you make during instrument flying revolves around this one idea. A standard rate turn means changing your heading at a rate of exactly 3 degrees per second. Now, why does that matter? Well, because at 3 degrees a second, you're going to execute a perfect 180-degree turnaround in exactly 1 minute. It just creates absolute predictability up there in the sky. Now, I know mental math in the cockpit can feel a bit overwhelming, but finding your exact bank angle for a standard turn is actually incredibly simple once you know the rule of thumb. Step 1. Divide your airspeed by 10. Step 2. Add 1/2 of that answer. To put that into perspective, let's look at the math here. Check out the bottom row. If you're cruising at 120 knots, you just divide that by 10 to get 12. Half of 12 is 6, add them together, and boom, you get an 18-degree target bank angle. You aren't expected to be robotic down to the decimal, but this gives you a really rock-solid target to aim for. Of course, you don't just guess that bank angle, right? You'll verify this math in the cockpit by checking the standard rate turn indications on the turn indicator and turn coordinator. You're looking for that specific 2MIN label, meaning 2 minutes for a full 360 degrees. Aligning your wings with those marks confirms you are executing the turn perfectly. All right, section 2, using the heading indicator, your primary instrument. Let's see how this builds into the gold standard for your daily turns. The reason we absolutely love the heading indicator is that it is gyroscopic, meaning it does not suffer from acceleration or turning errors. It completely ignores all those physical forces that totally mess with your other instruments. It gives you a highly accurate reading as long as you make sure to align it with the magnetic compass during steady flight. Okay, here are the steps for a heading indicator turn. First, fly at a steady speed, straight and level. Then, align with the magnetic compass. Decide the shorter way to turn. Check that the area is clear. Carry out a normal turn, commence rollout approximately 10 degrees prior to target heading, and finally, make minor adjustments. Now, the absolute pro tip here is commencing that rollout early. If you wait until you're dead on the number, your momentum is going to carry you right past it. Roll out 10 degrees early to lock it in. Moving on to section 3, timing with the clock, the reliable backup method. So what happens if your gyro is unserviceable? You step down the hierarchy. For executing a timed standard rate turn, step 1, determine the required change in heading. Step 2, divide the heading change by 3. Step 3, turn for that exact number of seconds. Remember our 3 degrees per second rule? If you need a 150-degree right turn, divide 150 by 3. It'll take exactly 50 seconds. And get this, if you look at your panel and realize you don't have a sweeping second hand, don't panic. Official training material literally says to time the turn using the second hand on the clock or by counting potatoes. I am not making that up. 1 potato, 2 potato, it sounds totally silly, but hey, it works in a pinch to keep your timing on track. Finally, section 4, taming the magnetic compass emergency fallback. We're at the very bottom of our instrument hierarchy here. You've got to be incredibly careful here because the magnetic compass suffers considerable indication errors in a turn. Due to how it's built, it sloshes around, it lags, it leads, especially when you're turning through north or south. It is practically unreadable during an actual bank. So the crucial takeaway here is that if you're flying in the northern hemisphere, you absolutely must memorize the number 30. 30 is your magic number to account for these massive compass turning errors. Here is how you apply it when turning north versus turning south. For northerly headings, the compass runs ahead, so you roll out 30 degrees before your desired heading. Undershoot it. For southerly headings, the compass lags, so you roll out 30 degrees after your desired heading. Overshoot it. If you forget that 30-degree rule, you are going to end up way off course. Thankfully, physics gives us a break sometimes. For equator operations, allowances are reduced when near the equator, for bank angles under 30 degrees, or when turning due east or west. In those specific scenarios, the turning errors naturally zero out a bit. And as a final huge trap to watch out for, just look at figure 18-6. The magnetic compass reads in reverse. East is on the left, west is on the right as you're facing it. You can imagine how that would easily confuse a stressed student pilot trying to find north in an emergency. Always trust your training on that one, not your instinct. So, which instrument will you trust on your next heading? We've covered the gold standard gyros all the way down to counting literal potatoes. You now have the practical cockpit guide to hitting your headings safely. But mastering these turns is really just step one. The next time you're up in the air, I want you to ask yourself, what other unseen physical forces are acting on your aircraft right now? And how exactly is your panel trying to warn you about them? Keep studying and trust those instruments.